All right, students, welcome back. We've been studying statistical measures of variation in our last few videos. Today, we are actually going to work on graphing those statistical measures. We're going to work on 3 different graphs that you're probably not that familiar with in 6th grade. And we'll use the definitions, and then we'll use some examples so you can see how to graph those statistical measures. So, get out your math journal, if you have it, or a piece of paper, and let's copy down these 3 definitions here of these types of graph that we're going to work with. The first one is called a line plot or a dot plot. Okay? It is a visual display of a distribution of data where each data value is displayed as an X or a dot over a number line. So that's why we call it a line plot or a dot plot, because you can either use an X or a dot to represent it. We'll see that later. We're going to do a histogram. A histogram is really just a bar graph. However, it's a type of bar graph that uses numerical values displayed in equal intervals. So it's from one number to another number. If that doesn't make sense right now, as soon as you see the example in a little bit, it will make perfect sense. Okay? Histogram and dot plot are not that difficult at all. We'll probably spend the majority of the time today on a box plot, or it's called a box and whisker plot. Okay? This uses a number line to show the distribution of data by using median, quartiles, and extreme values. So this is going to go along with our interquartile range and finding our median, and this is how to graph that interquartile range with the quartiles, the median, and the whiskers actually equal your high and low values. Now, not your outlier. An outlier will not be on the box plot. That's why it's an outlier. But your lowest extreme and your highest extreme that still fit in the data will be on your box and whisker plot. All right, we're going to move on. I know you haven't copied that all down yet, but you can pause this video and get that all written down. Okay? So we're going to jump right into line plot here. I'm going to turn this around, and we're going to kind of do a line or dot plot together. All right, so on this line plot or dot plot as we call it, here's my set of data. We had a number of pets. Okay, so this person has 1 pet, this person has 0 pets, 2 pets, 2 pets, 1 pet. Now, when you're doing a dot plot, okay, or a line plot, you have to have a number line that will represent your data. So, if you have to make up the number line yourself, which is true sometimes, okay, you're going to have to look at all of your numbers, put them in order from least to greatest is always a good idea, and see what do I need to cover. So on this number line, I have from 0 to 7, that is my range. All right, that's the numbers that I need to make sure that I have on my number line. Can I have more numbers than that? Of course. Would I want to have the number 30 on this number line? Obviously not. Okay, but if it went to 10, would that make sense? Sure. Okay, so just remember that whenever you create a number line to go with your data, you've got to know your data first to see what number line is going to be able to be used for that data. All right, so let's just start. I like to just cross them off as I put them on my number line. So I've got 1. So I'm going to put an X over the top of 1. I use X's in this because it's easier for you to see than a dot. Okay? You're just going to go, there's my 0. Okay, I want all of you doing this on your whiteboard. If you can, go ahead and draw this number line. And, sorry, I put a 0 there instead of an X, my fault. Draw this number line and start putting your X's over the top. Okay, I have a 2. You need an X over the top of that. Another 2. X over the top, a 1, another X there, I have a 3, put an X there, a 4, X, another 1, Now, it's important when you're drawing this out that you space your x's correctly and you keep your spacing the same. Now I'm not even doing that great a job right now, but you really want to do that because I'll show you why later when we're really trying to figure out what this line plot's going to help us to see. Okay, I have another 0 here. Put an x instead of a 0. I have a 2, a 5, a 3 again, a 0, a 1, and a 7. Okay, so you can see my line plot here, and you can see where my x's are at. Now, right off the bat, a line plot is the most helpful with mode. Okay? And Colby, the mode is the one that?
The mode is the one that occurs the most.
Occurs the most. So looking at this graph, Dalton, which one occurs the most?
1.
1. It's really easy to see because it has the highest amount of x's here, right? It goes up one above the others. Okay? If I were to say, explain the data or tell me about the distribution of data on this line plot, okay, you might say something like, most of the data is clustered, is a word we might use, between 0 and 3. Right? Can you see how we have a major cluster there? And then it would be easy for me to see really quickly, okay, most people have between 0 and 3 pets. All right? If I were to say, you know, what was the extreme value, the highest value, what would you say in our data? Dalton, what's the most extreme number of pets?
The most extreme number of pets would be 7.
7, okay, and we already know the least amount of pets was 0. Now, this is a line plot just showing you the distribution of data. Okay, it's pretty close together. Most of it's pretty close together. You have nobody with 6 pets in this group, but somebody, you know, could have 6 pets if you had a bigger thing of data. Okay, that's really what we're doing in a line plot. Now, you could work a line plot backwards. If you just had this graph and you didn't get this here, you could work it backwards and end up with the data, right? How many people said 1? 1, 2, 3, 4. So I would have 4 ones, just like I do in this data set. Okay, so you can work a line plot both ways. You can figure out what the data is here and here. You could find your mean, your average if you wanted to. We'd have to add all these up and divide by how many numbers there are. You can find your median, the one in the middle, okay? But can you look at a dot plot or a line plot and just be like, oh, this one's in the middle, this is my median? No. It can give you an idea of the median, but you still would have to list from least to greatest and find the one in the middle. Does that make sense? Okay, that's a line plot. All right, let's look down here at a histogram. All right. A histogram, I don't know if I gave myself enough space on my example here to draw it all out. But again, I have test scores. So just think about this in your classroom. We've got test scores. Now, look at the bottom of my bars for my bar graph. Okay? It says from 50 to 59. From 60 to 69, from 70 to 79. Do you see how you have a range there? Is that normal for a normal bar graph? No, you would just have one number, right? How many people got a 50? How many people got a 51, a 52? Well, that's what makes a histogram different. It lets you join the information together in a bar graph. Okay? Does that help? So I'm going around here to look at my definition again. It says, it uses numerical values displayed in equal intervals. Okay, so that's the important part when you're setting up a histogram. You have to have equal intervals. So if you're looking right here, 50 to 59, okay, 60 to 69, do you see how these are equal? Now, there's a common mistake made, not just by kids, but by a lot of people. Let's say I go from 50 to 60 here. Then I put from 60 to 70. What would be wrong with that? Dalton?
You have two 60s?
Perfect. Yeah, you can't use 60 twice. Because then if you got the answer 60, where would you put it? Does that make sense? So, if I went from 51 to 60 on this one, then I could have went from 61 to 70. That would have been fine because they would still be equal intervals, right? Okay, another thing that happens sometimes, you look at your data and you're like, oh, well, I'm going to go from 50 to 55, and then I'm going to go from 56 to 70, and then I'm going to go, you can't do that. Does that make sense? They have to be the same exact amount in these intervals, okay? And that's what keeps your bars the same width, because you're taking the same interval. All right, so again, I've got to look at my data here, and on this histogram, I've got to figure out how many, okay, so 55 is going in this category, right? I'm going to do a little tally down here. 55's there, 75's here, 72 is also here, 80 is right here, 96 is in this one, 65 is here, 77 is here, 84 is here, 86, 92, 93, 87, 65, 94, 81, 84. Okay, there's a lot of different ways to do this. This is just one way you could go about doing it and figure out how many are in each category. So, for my bar from 50 to 59, how many students, these would be the students over here, how many students got between a 50 and a 59? One. So my bar is going to go up to 1. That's it. Okay? There it is. Okay? Now, most of the time on a histogram that you'll see in your textbook, these bars are touching. You don't have space in between them. Okay? Sometimes when we draw them, we get a little space in between them, but most of the time they're touching. Okay, how many do we have between 60 and 69? 2. So this one's going to come just a little higher here to 2. And your bar is going to look like that. Okay, 70 to 79 goes up to 3. It rises up again a little bit higher. 3 comes across right here. Okay, you can see it's getting a little bit bigger. Okay, from 80 to 89, that's our highest one, right? It's got to go clear up here to 6. This is where I wasn't sure whether I had quite enough space, and I'll just make it here. Okay, so we can see from 80 to 89 on our histogram, we have most of our scores in there. And then from 90 to 99, we had 4. It drops back down to about here. Okay, so as a teacher, for me, I can look at this test scores on my histogram. I know that's not drawn beautifully, but you can see the idea, I think. And I can look on here and say, okay, most of my kids got B's. A lot of them got A's and B's. Okay, so that's really good. I had some C's, and then I had even less D's and F's, you would call, 50s and 60%. But anyways, this just gives me a really quick look at where my distribution is without doing a bar for every single grade. You know what I mean? If I had to do a bar graph for every one of these, scores, it would be so many bars it would be hard to read, right? So this histogram condenses that data a little bit for me and really shows me the distribution. Okay, so I can see where these kids are ending up. All right, so we've got a line plot with the X's above it. We've got a histogram with the bars. Again, the two important parts, getting your number line correct for your data, spacing it out correctly. I just counted by ones on this number line. You might count by fives, you might count by tens. You might, whatever works for your data is going to be what you make it. But again, you can't go 0, 5, 10, 20, 30. You can't, change your increments. They have to always be the same. Same thing we talked about down here. Okay? You might only go from 50 to 55, from 56 to 60. Those types of things, but they have to be the same each time in your increments. Okay, that is a histogram. Some of the questions that you could be asked on a histogram would be something like this. Which interval represents the greatest number of test takers? Which interval represents the least amount of scores? So, this one would be the most test takers. This one would be the least amount of scores. Those types of things. Those are just a couple. You might say, which interval has 3 scores in it? Which one would that be, Colby?
70 to 79.
Perfect. Okay. That seems pretty straightforward. There could be a few questions on there. Find the measures of center with this. You're going to have to use these and use the old methods that we've already talked about to find your mean, median, and mode. Just looking at the graph is not going to give you any of those directly. Okay? It's just going to show you how spread out and how the data is there. All right, now let's talk about the more difficult one today. We're going to talk about a box plot. Okay, so on the box plot, we're really trying to represent the quartiles, the first and third quartile. You'll be able to see the interquartile range and the range overall. We're really trying to represent this in a graph. So this is what we'll use this box and whisker plot for, to represent these quartiles, the first and third quartile, the interquartile range, the median, and you'll be able to see the range really easily with this as well. Okay, so on a box plot, at the top here I really just have it diagrammed to show you what each thing equals. So on my number line here, it's counting by fives. It goes from 5 to 85. Okay? You can see it's equally distributed. This end of the box is your quartile 1. So you would draw that straight line up and down matching to whatever quartile 1 was when you figured out your quartiles and your interquartile range. This end of the box is quartile 3. Okay? The median is going to end up somewhere in this box. However, it is not always in the middle. Okay? It's not always right in the middle of your box. The median is the middle of your data set, but it does not always come out in the middle of your graph. Because sometimes you'll have more numbers on this side, which is what would happen in this box plot, and that's why it stretches it out more here. They're further apart. And the numbers that you had on this side were closer together. Okay? That's what skews your median in the middle of your box. Now, this lower extreme is the lowest number in your data set. This upper extreme is the highest number in your data set, but those are not counting outliers. If it's an outlier, you would just put it out here somewhere, wherever it is. Maybe it's 8, maybe we had an 85 in this data set. And then you would label it outlier. Okay? It does not go in your box plot. It is not one of your whiskers. Can you see how these are considered whiskers? They just stick out like a little kitty cat's whiskers, one on each end. So that's why it's called a box and whisker plot. All right, let's try to create one of these. All right, so we've got the number of tickets sold is our data set that we're working on here. So the first thing that you want to do in a box plot though is put your numbers from least to greatest. You need that because you're going to have to find out your median. You got to find out your quartile 1, your quartile 3. You need to know all of those things and your lowest and highest number, right? So right now, let's write these numbers in order from least to greatest. I'm going to do that right down here. Hopefully you can see this on the video. I think 15 is our lowest number. Okay. The next number I see is 22. Does that look right?
Mm-hmm.
Dalton? Okay, I have 2 of those. I have 2 22s. After that, I believe it's 26. And I also have 2 of those. So I've got 26, 26. Here's 27. Then I have no 28, so I have 2 29s. I have a 30, 31, 32. Oof, I almost ran out of room. Then I have 2 36s. Hopefully I can squeeze these on here. Barely. Okay. Now, first thing we want to do is find the median. Who remembers how to do that? Go ahead, Colby.
So if you're finding the median, then you can like cross off the numbers like as you go to where it's like equal.
So you get to the middle?
Yeah.
Perfect. Dalt, is that how you like to do it?
Mm-hmm.
Okay. So we get rid of the 15 and the 36, the 22 and the 36, the 22 and the 32, the 26 and the 31, the 26 and the 30, the 27 and the 29, and that leaves, did I get it right?
Yep.
29 as our median. Okay. Now, Dalton, how do we find quartile 1?
You find the median from 29 and 15.
Okay, so from here to here,
Mm-hmm.
in this set of data, get rid of 15, get rid of 27, 22, 26, 22, 26. Uh-oh, where is it?
You have to find the average of 22 and 26.
Okay, perfect. What would that, 22 and 26 is 48,
22.
divided by 2 is?
24.
Okay, perfect. So, quartile 1 right here is 24. All right, Colby, same thing on the other end. What would quartile 3 be?
So it would be 31.5 because that's in between 30
Perfect.
and 32.
Okay. I didn't do too easy of numbers here for us on our first one. I've got a median of 29. I've got quartile 3, 31.5, and quartile 1 is 24. Now, here's one of the most difficult parts for you. Here's my number line. But I want to ask you this. What increments should I go by? What do I have to get to? You know, what has to be on one end and what has to be on the other end? Let's start with that. Dalton, what's the least number I can have on my number line?
24. Well, no, 15.
Okay, 15. Because I've got to have my whisker going to 15. Right?
Mm-hmm.
I don't believe this is an outlier. It doesn't look like an outlier. It's pretty close. I don't think 36 is an outlier either. So I'm going to have to at least have 15 here or less, right? And then Colby, what about the other end? Going to at least have to have
36.
36. So if I'm just going to, in my head right now, I'm going to throw something out there and see how it works. I'm going to start with 15. 15, 20, I'm going to count by 5s. 15, 20, 25, 30, 35, 40, 45, 50. I don't know, I got a little big, huh? Okay, so let's say I went by 10s. No, that's going to be too big. Let's say I went by I went by 5s, let's go by 2s. So let's say what if I started with 14, 16, 18, 20, 22, 24, 26, 28? Nope, didn't make it.
3.
Okay, so maybe what I want to do then is let's count by 5s, that's probably a good increment, but maybe let's start with 10. 10, 15, 20, 25, 30, 35, 40, 45, and I drew this before we even started. So I'm going to start with that. Okay, I think I'm going to use my black pen here to kind of help you out. 10, 15, 20, 25, 30, 35, 40, 45. Okay, now here's a common problem that kids run into. Well, my median was 29, so I want to make one of my number lines 29. Well, what are you going to count by to get to 29? It's ones? So then what? You're going to count from 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, all the way to 36? That's not really going to be helpful or smart. Okay, you're going to have way too long of a number line. So it's okay if it's 29. It's just going to be one less than 30 here. All right, so let's start now to make our box. Okay, I like to start, if I know my quartile 1, it's 24. So 24 is right above there. I'm going to make my line right there on 24. My median is 29, which is going to be a straight line right here on 29. And then my quartile 3 is 31.5. 31 and a half is about right there. So now I gotta make this nice looking box here. Okay, like that. My whisker is to 36. I'll put a dot right here at 36. And then my other whisker is to 15. I'll put a dot right here on 15. I'll connect those. Okay, now remember, this line is your median. This line, quartile 3. This line, quartile 1. Okay? Now again, I'm using a graph to help me see the distribution of data more clearly or easily. Okay? So obviously one of the things a box plot gives you really quickly is the what?
Median.
Is the median. You can look at it right away, that line down the middle is the median. You can go right down and say, oh, okay, that's about 29. All right? It also gives you your quartiles really quickly. And in giving you your quartiles, what does it give you?
Your inner quartile range.
Perfect. It gives you your IQR, your inner quartile range. We just subtract these two. 31.5 minus 24. Okay, that's a little harder math problem, but it's 6.5 or 7.5? 7.5. Okay, so it's 7.5 is my IQR. All right? Now, would you say this data is really close together or really spread out?
Close together.
Yeah, because look at this box plot. It's pretty spread out compared to this box plot, huh? It's squished together. So you can look at this box plot really quickly and know, oh, my data is pretty close. All right, the number of tickets sold by the kids, they're all pretty close together. You can see. Okay, one kid didn't do very good, and one kid, he beat everybody. You see what I'm saying? So it's a way for me to be able to talk about the data and see it. If I'm selling tickets at school, let's say, this is kind of like selling candy bars for our Sonora trip or whatever. If I had a box plot like this, I could see really quickly, how are we doing? How are the kids compared to each other? What's our median number of boxes sold? That kind of thing. So that's really what a box and whisker plot is supposed to do. You're going to have questions on your iReady third quarter test or the test 3, whatever we call it. And it will ask you sometimes, what does this represent? You know, and you're going to be like, this part of the box, you'll be like, oh, that's quartile 1. Now you should know that. Okay, this is all pretty new to you. Oh, this end of the box. Oh, that's quartile 3. Okay, those types of things. On the worksheets that I'm going to give you to practice, it's going to ask you a lot of questions on explain. Let's see how it says it here. It says, write a sentence describing what the length of the box plot tells you. You know, explain the distribution of the box plot. So you're just going to have to say in words things like, well, the interquartile range is this. You know, the median is this. It shows that the information is very close together, very spread apart. Those are the types of answers you will write when it asks you to explain, you know, how the box plot shows you the variation in different things. Okay, my two kids, you have any questions on any of those? Think we got it?
Mm-hmm.
All right, thanks, and I'll probably give you an update on the box plot in another lesson later.